Stellar mass black hole. This is the most common and well-understood type of black hole. It forms from the gravitational collapse of a single massive star at the end of its life in an event called a supernova. To form, the star's remaining core must be more than about 3 times the mass of the Sun. Typically, stellar mass black holes have a mass between 3 and a few dozen times that of the Sun, all compressed into a sphere ranging from about 10 to a few hundred miles across. They are found scattered throughout galaxies, often detected when they are in a binary system pulling material from a companion star, or when 2 of them collide and send gravitational waves rippling across the universe. Supermassive black hole. These are the largest confirmed type of black hole. They have masses ranging from millions to billions of times that of the Sun. The most massive ones have event horizons larger than our entire solar system, though even a relatively modest supermassive black hole would have an event horizon dwarfing the Sun by a factor of millions. A supermassive black hole sits at the heart of nearly every large galaxy, including our own Milky Way, where Sagittarius A star weighs in at 4 million solar masses. Their origin is not fully understood, but they are believed to have grown over cosmic time by merging with other black holes and consuming vast amounts of gas and stars. When material actively falls into them, they power quasars, the brightest sustained objects in the known universe. The energy they release can regulate star formation across an entire galaxy, making them the gravitational and energetic anchors of the structures they inhabit. Intermediate mass black hole. This is the elusive missing link between stellar and supermassive black holes, with masses ranging from hundreds to hundreds of thousands of solar masses. Their existence was long theorized, but confirmed candidates are rare and difficult to find. They are not massive enough to dominate a galaxy's center, and not common enough to be caught pulling material from a companion as often as stellar mass black holes are. Evidence suggests they form from the repeated mergers of stellar mass black holes, or from runaway collisions of massive stars in the dense cores of globular clusters. They are the most likely seeds from which supermassive black holes grew in the early universe. Primordial black hole. This is a hypothetical type of black hole that formed not from a collapsing star, but from the extreme density fluctuations of the universe in the first fractions of a second after the Big Bang. Unlike stellar black holes, their size is not constrained by the physics of dying stars. They could range from the mass of an asteroid to thousands of times the mass of the Sun, depending on the density of the region that collapsed. The smallest primordial black holes would have already evaporated completely over the age of the universe through Hawking radiation. If larger ones exist, they would be invisible and effectively undetectable by any current instrument, which makes them a leading candidate to explain some or all of dark matter. Microblack hole. This is the most extreme theoretical type and the smallest a black hole can be. Microblack holes sit at or near the Planck scale, the absolute minimum size permitted by the known laws of physics, with masses starting around 22 micrograms and diameters smaller than a proton. No mechanism in the observable universe currently produces them, but some theories of quantum gravity and extra dimensions predict they could form at energies far beyond what any particle collider has reached. A microblack hole would evaporate almost instantly upon formation, releasing its entire mass as a burst of Hawking radiation in a fraction of a second. They have never been observed, but understanding them sits at the boundary between general relativity and quantum mechanics, the place where both theories break down and a unified theory of physics would need to take over. Thanks for watching. If you enjoyed this video, then be sure to like and subscribe. It helps me a lot.